Okay, guys, we have our introduction on monomials. And first off, I'm just going to show you all the rules and things like that. In my next video, I'll have a lot of examples. Okay, so the definition of a monomial is a number, a variable, or a product of a number in one or more variables. Okay, so I have some examples of monomials. 1 over 20s squared. Okay. That's a product of a number and a variable, okay? -5 is a monomial, it's a number. Simply x, it's just a variable by itself, that makes it a monomial. And then a times b times c to the 8th all over 5 is also a monomial because it's a product of one or more variables and a number, okay? Anything adding together like x plus y is not considered a monomial. This is not a monomial because it's not a product of a number of variables. That's you're adding two variables together, so that is not a monomial. All right. All right. So the important thing about monomials that we need to be learning is how to simplify them. And there's two simple questions you ask yourselves when you're simplifying a monomial to decide whether it's all the way simplified or not. Okay, the first question is, do I have any negative exponents? If you have negative exponents, your monomial is not simplified. Okay, and then the second question you ask is, are all of my like bases combined? Okay, and if you remember when we talk about exponents and powers and things like that, if you have a power, 2 written to the third power, okay, the base is this, okay, that's considered the base, and the 3 is considered the exponent, and this whole piece is considered a power. Okay, so whenever I say like bases, anything that else that has a 2, or it could be anything else that has x or something like that, you got to make sure they're all combined, okay? So we'll get into that a little bit more whenever we start doing our examples. There's a couple of rules that you need to follow when you are simplifying monomials, and it's broken down in here to 4 different rules. Really easy. Whenever we're doing this right here, all of those are on your green sheet of paper. So you can have those, you can write them all down, but these need to be committed to memory because you will have to do them without any notes, okay? So the first one is power to power. Okay, so I have it's my base, and it's raised to an exponent of m, okay? And then I'm saying that a to the m is then raised again to n. So that's why we call it power to power. This is a power raised to another power, okay? So whenever you have a power to power, something raised to another power, okay, you simply multiply the exponents. So my answer would be a raised to the m times n. All right, so I have an example here with actual numbers. All right, 2 is our base and 3 is our exponent. And then it's then raised to the third power, which means that I need to write 2 to the third 3 times. Okay, so if I have 2 to the third 3 times, I have a total of 9 2's. So all you simply do is go 3 times 3 is 9, and that simplified is 2 to the 9th power. Okay? All right. Here's another example with a variable as the base. It's raised to the 4th power. It needs to go 4. There's 4 x's that need to be written 5 times, which will be x to the 20th. Okay? So that's the first rule, power to power. So all your power to powers have to be simplified. All right? Product of powers. All right? These are two powers that have the same base. That is very important when we're doing this. They have to have the same base. Okay, notice I don't have an A and a B here. It's 2 A's. They have to have the same base. So when you're multiplying 2 products that have the same base, or 2 powers that have the same base, all you simply do is add their exponent. Okay? So 8 raised to the m times a raised to the n is a raised to the n plus n, okay? And this little multiplication sign isn't always between two powers, okay? You know that if you have two things next to each other, they're not stuck together, they're being multiplied together, and that's really hard to understand when we're talking about monomials, that these aren't stuck together, they're two separate things, and then you can combine them. So 2 to the 4th power times 2 to the 3rd power is the same thing as saying 2 to the 4 plus 3, which is 2 to the 7. Okay, if you wrote this all the way out, you have 4 2's and you have 3 2's, okay, then you have a total of 7 2's. All right, so that's our next rule. All right, quotient of powers, okay, that's quotient. What does quotient mean when you're dividing? The answer of a division problem, okay, so when you're dividing two things, again, you have to have the same bases here, A and A, whenever you're going to apply this rule. It can't be, you know, X and Y. Those are totally different bases, all right? So A and A. Whenever a number is being divided by another number, you simply subtract the exponents, okay? So A to the n power divided by A to the n power is the same thing as saying A to the m minus n. So I subtract the exponents, okay? It's an easier rule than simplification, okay? I could write out 2 to the 5th, 5 2's, and 3 2's, and they're going to cancel to be 2 2's, okay? But it's a general rule when we start getting bigger numbers that if you have the same base and you're dividing, you subtract the top minus the bottom. So 5 minus 3 is 2. Okay, so if I were to write that out, it would be 2, 2, 2, 2, 2 divided by 2, 2, 2. And you do your simplifying, which there's 2 left. Okay, just a shortcut here rule. Our last rule is a negative exponent. Okay, and that's one of our questions over here. Do you have any negative exponents? It can't. Your monomial can't be simplified if you have negative exponents. All right. Now, when you have a negative exponent, this is telling me how many times I want to divide by A. Okay, so I want to divide A this m times. Okay, so all you simply do when you have a negative exponent is put it at the bottom of a fraction. Okay, since I'm saying I want to divide A m times, so 1 is being divided by A m times. When you move it down to the denominator, it makes the m positive, okay? So if it's on the numerator, you move it to the denominator, it makes it positive. And vice versa. If it is on the denominator, you simply move it to the numerator, and it becomes positive. So once you make your move on your negative exponent, then it becomes positive. Now, does this work for negative numbers or negative coefficients? Absolutely not. If you have a negative 12, A to the, we'll say negative 2, you can't move that 12 down to be positive. It has, this rule does not apply with negative coefficients, okay? So this would simply be negative 12 times 1 over A to the 2nd power. And I'll do a lot more of these examples here in a minute on our next video, okay? So same thing here, 2 to the raised to the negative 3 is 1 over 2 to the positive 3. All right, and that is an introduction to monomials. Watch the next video for more examples.